All right, we're moving into different systems of equations. Now we have an x, a y, and a z. So as you can see, we now have what we call three variables, x, y, and z. And we are doing systems of linear equations in three variables. The first way that we're going to learn to solve these is we're going to use what we call back substitution. So back substitution makes it super easy because they already give you a z. So all I need to do is plug that 3 in for z. So 2y minus 3 equals 7. And now we can solve for y. 2y is equal to 10, and y is equal to 5. So far, I know that I have a 5 and a 3. And guess what we're going to do to go ahead and solve for x? We have to take the 5 in for y. We're going to take the 3 in for, z. I didn't mean to circle that x there. And we're going to solve for x. So let's go ahead and do that. I'm going to do that in purple right here. So I have 3 times what plus 5 plus 2 times 3 is equal to 8. 3 times what plus 5 plus 6 is equal to 8. 3 times what plus 11 is equal to 8. 3 times what is equal to negative 3. So guess what that x is equal to? X is equal to negative 1. So we are going to show our answer in a parentheses with a negative 1, a 5, and a 3. All right, let's get going on this one. How do you think I could do the next one? So let's look at this next question. This next question in the second equation, I don't have a y there. I'm going to put that on the top. 2x plus z is equal to 8. And I'm going to try to get rid of the y between another one. So I'm going to combine 2. So if I combine the first and the third, couldn't I multiply the first through by negative 3? I'm going to do that down here. So if I have negative 3x minus 3y minus 3z is equal to negative 15, now my y's can cancel out. So when I add down, I have negative 3x minus z is equal to negative 10. I'm going to write that right here. And now, just like systems of equations, I can solve this for x and z. So if I solve this for x and z, I can add down because these z's will cancel out. And I get negative x is equal to negative 2, where x is equal to a positive 2. I'm going to write that right above. If I plug that 2 back into the original, 2 is going to go back into the original. I end up having 2 times 2 plus what gives me 8. 4 plus z is equal to 8, where z is equal to 4. Well, good. I have my z, which is 4. So now I have to go back to an original and solve. So I'm going to go back. I'm going to highlight it for you. I'm going to go back to this original right here. And I know that x was 2, y is what we're solving for, 4 is z. So let's solve this. We have y plus 6 is equal to 5, because I added the 2 and the 4, where y is equal to negative 1. And again, you could plug all of these back in and try them and see how you do.